Hello, Tim Bushnell here with Expert Cytometry and on another edition of Wednesday's Wanderings. Today I wanted to talk about tips for improving the quality of your data. And really starts with how do you approach your data analysis process. And it really can begin in experimental design and when you sit down at the instrument. And we'll talk about that. But the first thing I want to highlight, my first point today are the idea of keywords. You are able to add keywords to your flow cytometry data right when you're setting up your experiment. This QC process of adding these keywords allows you to better search your data, better characterize your data, better remember what your data was. So if you build an ontology and you know how you want to describe the parameters that you're using, what fluorochromes, what antibodies, that will make it easier to set up your analysis downstream. The second point that I'd like to raise is the idea about developing a quality control program. So yes, the people running your instruments, the core directors, the shared resource laboratory personnel are doing quality control on the instrument, but they can only do it for the machine usually when the system starts up. If you're using the machine at 2, 3 in the afternoon, well then there might have been some issues and you might want to consider adding your own quality control. This is very easy to develop. Grab a bead. I happen to use the Peak 6 bead from Protect, but any bead that you want can be used. When you establish the quality of your data, when you set up your data workflow, when you're doing your the developmental process and the validation process, you're going to identify target values, fluorescent intensity target values, using that bead based upon the voltages that you're using to set up. Now, every time you go to the machine, you check those values. You set up a template and you measure those values. You make sure that you're hitting those target values, and you not monitor how much voltage difference you need. If you see a large difference in the voltage, it's a good time to talk to the core people and find out what might have happened, or potentially have to clean the instrument. So this saves you from having poor data generally that has a wider CV or less robust by having that quality control program that you are responsible for. The third point I'd like to bring out is what I call trust but verify. A lot of the software packages for analysis now have an automatic wizard that will do compensation for you. And compensation is such a critical component of your flow cytometry experiment to get right that you shouldn't just allow the wizard to do it without verifying and looking at the data. There's examples that show where the wizard might get the wrong forward scatter, side scatter, because you have a lot of debris in one tube or something, or there might be other issues related to how the wizard grabs and identifies the positive negatives. So run the wizard definitely, but go ahead and check and make sure that you're getting the right sample and right values for the positive and negative gates. The fourth point today, and we've talked about this a lot and I'll highlight that later on, is proper controls for your experiment. And this is going to include things like the fluorescence -1 control that will help in setting gating up. This would include things like an unstimulated control, a reference control so you know that your experiment is working, and that goes back to the second point about developing a QC panel. You may need to run, like I said, unstimulated. Other controls that will help you identify the populations of interest become important, and you need to make sure that you've figured out what those are. Again, that should help in the developmental process of building your panel. The last point which I want to bring up today is to make sure you extract the correct data. And this is actually something that you should establish at the beginning of your experimental process, which is establishing the criteria that you're going to use to determine if your data is statistically significant, if you're doing hypothesis-driven science. Discovery level science, we don't have to worry about the specifics on the statistics that we'd be doing because we're not looking at statistical analysis in the same way. But what we do want to make sure is that we're extracting the right data. Know the questions you're trying to answer and get the data that will answer those questions. So if you're going to be looking at expression level data, you're going to want to get the expression, the fluorescence intensity, median fluorescence intensity values of the population that you're interested in. You're probably also going to want to get the standard deviation, the spread of the data around that you'll be able to use. Make sure you identify the right controls so that you can properly compare your data to this, so you have a good positive control, a good negative control, and that the controls are treated the same way. So if you have a one-color experiment, an unstimulated versus stimulated, make sure that you have a stimulated, unstained control to help you set your gates properly. So with that, those 5 points again, make sure you're using keywords, add those right at the beginning, figure out how you want to label them, make sure you label them consistently. 2, develop a quality control program for you and your experiments. 3, trust but verify any wizards that you've used. 4, make sure you've got the proper controls for gating. And last but not least, number 5, make sure you extract the correct data. So with that, I'd like to say thank you, and we'll talk to you again soon.